values or the results of each equation. Okay, and so we're going to focus on that idea and also on a matrix that's not augmented, just the coefficient of matrix. So let's take a look at a share. This is something that should be in your news items. These are matrix operations. So when we look at a matrix, okay, the first thing we can do is we can do this idea of scalar multiplication. Let's take a look at a matrix in general. So the definition of a matrix in general, we have what's called an M by N matrix. As we saw with the calculator, this deals with rows, this deals with numbers of columns. Okay, now when we deal with a matrix, we like to identify each item in each cell. Okay, there are lots of ways we can do that. One way we can do it is with the subscript method. This deals with where it comes from, what row it comes from. Second number deals with what column it comes from. So when it says 1 in the first subscript, that means it's the first row. When it says 1 in the second subscript, that means it's the first column. So when we see something like 1 by N, that means it's first row, nth column. Okay, so that's where the N comes in and ties in here. So all of these should have the second subscript of N at the end. When we see something like M1, that means it would be the mth row, first column. When we see M by N, that means mth row, so the last row, N columns. So those are just general subscripts we use. So let's go down to this one for a moment. Okay, let's look at this 1 right here in that third row, second column. The subscript for this item would be, say we call it matrix A, which we did. So that would be lowercase a, and it would be subscript of 3, 2, because it would be third row, second column. Now look at this one. Okay, that 1 right there in that second row. So that would be second row, third column. So the subscript for this would be lowercase a. So that 1 is equal to lowercase a with a subscript of 2, 3. Now, as it turns out, remember the diagonal was pretty important when we did row reduced echelon form. And with the diagonal, this is going to be first row, first column. The next item in the diagonal will be second row, second column. And the third item in the diagonal will be third row, third column. So if it's a matrix that we call a square matrix, which has the same number of rows and columns, those items in that diagonal, that main diagonal, will always have the same subscripts. The values will be the same for each. So now let's take a look at the first type of multiplication we can do. The first type of multiplication we can do is called scalar multiplication. Scalar multiplication literally means you're going to scale. You're going to shrink the matrix. You're going to increase the size of the values in the matrix. That's why it's called scalar. Okay? So scalar is a real number. We'll call it C times A. So that's equal to whatever that number is times the entire matrix. And all you do with scalar multiplication is just multiply each element within the matrix by that number. Okay? So let's take a look at this example finally. So let's suppose A is equal to, going across the first row, 2 minus 3, 2. Second row is minus 3, 0, 1. And third row is 8, 1, minus 5. And let's suppose that our scalar is minus 4. So what would this do? This decreases the size, or rather, if you want to think about it, the minus actually changes direction. But minus also decreases, it makes it smaller. Negative, remember, makes it smaller by a factor of 4. But we look at this as changing the direction by a factor of 4. In order to add, so if we did this, we would multiply, let's finish this up before I go on to the next one. We multiply the 2 by 4, the minus 3 by 4, and the 2 here by 4. So that'd be 8 minus 12 and 8 across the first row. The second row would be minus 12, 0, and 4. Then the third row, we multiply through by minus 4, minus 32, minus 4, and 20. In order to add matrices together, we add the common elements. The common elements have to be added together. So the matrices have to be the same size. In other words, they both have to be the same number of rows and columns, because they have to have something in the other matrix to match up to add with, and we just add it together. So if I have a matrix A and a matrix B, they're both m by n, I would just add the first element in A, A11, with the first element in B, B11. I'd add the second element in A in that first row with the second element in B in that first row, and so on. Okay, so we just add element with element. So when I look at, so I want you to try a few of these examples, and then we'll come back to them later, just for practice. But when I look at these, I'll give you the answers later. When I look at these, A plus B, okay, that's the first one I want you to do. I'll get you going on this. So A plus B, I'd add the first element here with the first element here. That'd give me a 4. I'd add the second element here with the second element here in that first row. That would give me 2. I'd add first row, third column, first row, whoops, third column. That gave me a 1. I go down to the second row. I'd add first item rather, in the second column, or second row, with first item in second row. -3 and -2 give me -5. I go 0, 1, that gives me 1. 1 plus 1 gives me 2, and so on. When I have minus, I distribute the negative and then add up. So this B, I would have to distribute through with a minus, so that'd be a -2, a -5, that's just a scalar multiple of -1, and a 1. So when I add up, 2 minus 2 gives me the 0, -3 minus 5 gives me the -8, and 2 and 1 give me the 3, and so on. I want you to try these to see if you get the same answer. Okay, practice this before you do your homework. When we have scalar multiples in front of the matrices, we do the scalar multiple first, then we add. A more difficult procedure is matrix multiplication. We'll take a look at that next time.